Hi everyone. We're going to talk about spectrophotometers, and we'll begin by distinguishing a single beam instrument from a double beam instrument, and in other videos we'll talk about the components in a spectrophotometer. So let's begin with the single beam instrument. You've seen this before. Remember, we have a light source followed by a wavelength selector, then the sample, and then a transducer. So when using a single beam, first you put in the blank to zero the instrument, and I don't know if you realized it or not, but when you were doing that, you were determining P sub naught, then you had to dump out the blank, rinse the cuvette, put in the sample, you'd measured the sample, and that's how you got P. So if you remember using a single beam instrument, it got to be a little bit time consuming because you always had to re-zero the instrument. Let's compare this single beam instrument, and again we have a single beam from the source all the way to the transducer. Let's compare this to a double beam instrument. Well, we're going to begin with a source and a wavelength selector, but after the wavelength selector there's a mirror, or sometimes it's called a chopper, and this mirror or chopper moves. And when it's in this position, radiation leaving the wavelength selector can make it all the way to the sample. But when the mirror is in this position, radiation is going to bounce off of the mirror, strike another mirror, and then pass through a reference or a blank, giving you P sub naught. So because this mirror is constantly being moved by a motor inside of the instrument compares P and P naught for you. You don't really have to zero as often when using a double beam. So you can see how there's two beams, one through the sample and one through the reference. Here is Harris's version of a double beam instrument, and I think it's pretty similar to ours. There's a light source, the monochromator. Here is that rotating mirror or the beam chopper that can alternately pass through the sample or through the reference. And here is a look at this double beam instrument. Here's what it looks like with the cover on. And in this diagram, we've taken the cover off. And let's see if we can maybe identify the major components of this instrument and see those two beams. So here we have the light source, and this area is the wavelength selector, and this is the exit slit of the wavelength selector. So radiation leaves that wavelength selector, strikes the mirror here, strikes another mirror, and strikes another mirror. And right here, this is the chopper. Harris has identified it for you here. So half the time, radiation passes through this chopper, strikes this mirror, and passes through the sample. Again, this is how you're getting P, but the other half of the time, radiation bounces off of the chopper, strikes this mirror, bounces off, and passes through the reference. Remember, that's how we got P sub naught. And from there, radiation strikes this mirror and enters the transducer, which in this case is a PMT. So I hope you understand the difference between a single beam and a double beam instrument. Thanks for listening.